No, see, now that's way too fast. So that can't be right. Wait. Chat, we'll figure this out. No, it's not me. What am I doing? Chat, I feel like you've turned me around all the way backward. It's gotta be divide. Is the mathing? Oh my God. It'd be meters per second. What am I getting wrong? I know, I'm seeing if that's what they meant. It should just be this, right? Yeah, I had this this was the first freaking thing that I did. Just don't understand how they got the next part. I'm going on what the codex itself said in the game. Didn't get far in the game at all. All we did was spend an hour talking about this. Could I make a whole video out of this? I don't know. But it does annoy me.
And so, here we are. I love the Mass Effect games for many reasons. The dialogue, the characters. Oh, Arya, I said Mass Effect.
Sorry, beep boop.
The characters. I especially love the series for trying to incorporate real space science into the games. But here's the problem. Some very cool Mass Effect math has been wrong for nearly 20 years, and no one has known why. Until now.
Now entering the facility.
I don't have many problems with the Mass Effect games aside from this obviously American politician, but when the games go to the trouble of being more science-y than most, I can't stand it when something stands out more than a reporter's punchable face. And that something is this.
This is the Citadel, an artificial hub world for all the galaxy's spacefaring species. It takes its inspiration from actual space station designs like the Stanford Torus and the O'Neill cylinder. The Citadel looks like these famous images from 1975 and 1976 respectively, because if humanoids are to live in space for extended periods of time, our bones, circulatory systems, and faces prefer to live under gravity. The theoretical torus and cylinder generate this gravity by spinning. Spinning is a good trick that can mimic gravity in space through fictitious forces.
You know when you're driving a car and you take a tight turn and it feels as though you are being pushed to the outside edge of that turn? Well, that force you're feeling is fake. It's fake in the sense that to anyone outside of the car, there is obviously no one inside forcing you to one side or the other.
Instead, your body is moving along with the car, and when it turns, your body wants to continue in a straight line. Inertia. But the friction of your butt in the seat and then the belt across your chest moves you along with the curve. In the car, it feels like a hot Asari biotic commando is pushing you outwards with some invisible force that you're actually totally into, but the reality is that the car is simply forcing you to move along the curve, with force. This difference between observers is why the centrifugal force is considered fictitious and the centripetal force is not.
Centripetal acceleration is how the Citadel generates artificial gravity. By spinning, all the inhabitants in the wards and the Presidium will feel as though they are pinned at their feet to the inside edge of that gigantic structure. The trick is to get all the numbers correct, the rate of rotation, the radius, so that that pinning feels just like gravity does on a planet.
But it is the numbers that are the problem with Mass Effect Citadel.
Why did I find this poster in your captain's quarters?
What? That's not mine. I don't even know if that's a poster of a character named Miranda or not. Today's episode is sponsored by Display. Gamers, I'm award-winning science educator and nuclear poster boy, Kyle Hill. You know, if you're like me, you have an ever-expanding menagerie of nerdy art that you want to display. But you want something that looks great and stands the test of time. Paper posters are so college dorm room. That's why I'm very happy with the new collection I've started with today's sponsor, Displate. Displate is a unique metal poster company that perfectly caters to your nerdy needs. They have licensed art from Star Wars, Marvel, and Elden Ring. They have custom pieces from independent artists. In total, they have over 2 million posters to choose from. The real innovation here is the quality metal artwork. These posters use magnets to quickly and easily stick to your wall. Simply adhere the magnet and let quantum mechanics take over. Because they are metal, they are both interchangeable with any other displays in your collection, and they don't fade and wrinkle in the same way that paper posters do. Metal also allows for Textra, Displate's latest product that adds undeniably satisfying three-dimensional texture to your posters. I'm extremely happy with the quality of my new Arcane, Atomic Heart, and Fallout displays. If you want to start your own collection, click the discount link in the description to get 26% off for 1 to 2 displays, or 30% off for 3 or more. You have so many geeky passions. Let people see them. Display them. Better yet, displate them.
Thanks to Mass Effect nerds, the entire Mass Effect Codex is now available online. And according to that codex, the Citadel does in fact generate the majority of its gravity via centrifugal, or in our case, centripetal forces. The Citadel itself rotates once every 3.5 minutes, and the citizens of the wards in those long arms are pinned to its sides with 1.02 Earth gravity. That's 1.02 times the normal gravitational acceleration on Earth, which is 9.81 meters per second per second. In the Presidium, which is that much smaller ring at the center, it's 0.3 Gs. These two numbers at least make sense. If you keep the rate of rotation the same, because these two rings in the Citadel are connected, then the further you are out from the center of rotation, the more centripetal force you will feel. Because with the same rotation rate, you're covering more distance in the same amount of time than the smaller ring is. More distance over time is more speed is more velocity is more acceleration, which is more force. Now, if you know the equation for centripetal acceleration, you know that R is in the denominator. We'll get to that in a bit. So wouldn't a larger radius for the wards mean actually a lesser force? Well, no. Because here specifically the rate of rotation is the same. Think of it this way. If you had 3.5 minutes to go around a very small track in your car, you could get a pretty leisurely pace going, right? And you wouldn't have to take all those hard corners. But if you had to get around a giant track in that same 3.5 minutes, you would have to go much, much faster, right? And then you're driving effectively, turning left the whole time, you're driving like a mass car. Effect. Hey, did you know that we have a gaming channel? We do this kind of thing all the time. We science your favorite games just like this. I'll show you what we got up to last week.
What is that?
It's nothing. I'm but a student of xenobiology.
This is the equation for centripetal acceleration. As you can see, it depends on the tangential velocity at the edge of rotation and the radius of that rotation or rotating thing. Let's check the Citadel's numbers. Start with the Presidium and 7.2 kilometers in diameter. Multiply that by pi to get the circumference, divide that circumference by the rate of rotation to get the tangential velocity, square that, and then divide it by d over 2, or diameter over 2, to get the radius, and then we plug and chug and we get, bam, exactly the right answer, 0.3 G. Now all we have to do is do the exact same thing for the wards numbers at 12.8 kilometers in diameter, and we get, bam, exactly the wrong number. Why?
Why? Why in a game so filled with sciencey stuff is this one number wrong? Mass Effect lore accurately calculates the kinetic energy of a railgun round, but can't do spin gravity? This is the only glaring numerical error in the codex as far as I can tell. So it's frustrating for a sci-fientist like me, until you know why this number is wrong. It's wrong because there's a difference between science and telling a story.
A common thread throughout a lot of sci-fi movies throughout the years, whether it's 2001: A Space Odyssey or The Martian or Interstellar, is the use of centrifugal or centripetal rotational forces to create artificial gravity. But there's something that Hollywood doesn't want you to know. There's another way, and it might actually be easier. Imagine you're the engineer tasked with designing an interplanetary vessel for long-duration spaceflight that also needs to create artificial gravity. It's already difficult to design long-duration space vessels, as you have to have all the requisite life support systems and radiation protection and so on. Now imagine you need to make the whole thing spin. But remember, all artificial gravity is us harnessing acceleration. Rotational acceleration works just fine, but what about linear acceleration? You know that feeling when your car accelerates from rest really quickly and you get pushed into the back of your seat? That's your inertia wanting to keep you in the chair. Imagine a vessel whose living quarters, instead of being parallel to the direction of motion like you might see on a cruise liner or a battleship on the ocean, instead has its living quarters perpendicular to the direction of motion. So that way, when the ship is accelerating this direction, you on the floor are being pushed down into the floor and the floor pushes back up on you, simulating gravity. All this linear gravity system would require is a ship that can accelerate constantly for the duration of the spaceflight at 9.8 meters per second squared, which is Earth's gravitational constant. The problem here isn't construction, it's fuel. The sheer amount of fuel required to accelerate constantly for the entire duration of an interplanetary voyage is staggering. Until we solve this problem with a more intelligent fuel mixture, or maybe a more intelligent method of nuclear fission or fusion to fuel our rockets, this unfortunately lies in the realm of science fiction. But according to a paper from NASA, if we are able to solve it, there is an added benefit. According to co-authors Buckley, Poloski, and Clément, a spaceship accelerating then decelerating at 1G would reach Mars in 2 to 5 days, depending on the relative distance. So next time you see a sci-fi movie with a big spinning centrifuge on a massive ship in the vast expanse of space, just remember that that director could have saved their VFX artists a ton of time if they just made it a long tube instead. Why should Neil deGrasse Tyson have all the fun ruining people's enjoyment of sci-fi movies on Twitter? You can do it too. Fire off those 280 characters about it, King. You got this.
Here's a fun fact for you. The famous Sir Isaac Newton is the deadliest SOB in space speech is given by an NPC to 2 servicemen. One of them is named Chung. Chung is a reference to Winchell Chung, curator of the nerdiest website you will ever read, Atomic Rockets. The website is a near bottomless treasure trove of hard sci-fi information. Here, scientists, researchers, sci-fi writers, and just enthusiasts have spent years collecting a nigh-complete repository of sciencey stuff that those looking to tell more accurate space stories can use. I have made multiple videos using this website, and it's also where I met original Because Science super nerd Matterbeam. When I started researching this video, I remembered this connection and went to Matterbeam's Discord to talk about Mass Effect. I got this response, no joke, in under 60 seconds. Oh, hey, I know the guy who wrote the entire Mass Effect Codex. Do you want me to ask him about this? The galaxy may be big, my friends, but the nerd world can be pretty small. Solving my Mass Effect math mystery was Chris, the former canon keeper at BioWare. Now keep in mind that Chris hasn't worked on Mass Effect in nearly 20 years and is speaking only for himself and not for BioWare. But according to Chris, the discrepancy I noticed was because many numbers in the Codex were deliberately skewed. Why? To keep gameplay consistent. The Unreal Engine that the games use can implement variable gravity, but that wasn't the game BioWare wanted to make. They wanted running, jumping, ballistics, everything you'd notice and have to adjust to as a player to be the same across the game's many locations. So the inconsistency in the Citadel numbers is explained by the fudge factor of Mass Effect fields for gameplay reasons.
Now I know this is going to be a disappointing ending for some of you. Space Child. But I think it's actually a really important learning experience. Whenever you make any kind of science fiction, there is inherently a tension between science and story. The accuracy that you want to have and the tale that you want to tell. I think that some sci-fi critics forget this point. This is really important for an armchair physicist like me. Why are Mass Effect numbers not totally correct in all circumstances? Well, because they want the game to play well. I think this is something I'm going to internalize, and I really think I learned a lot today.
But Kyle, what would we need to make the Citadel numbers correct?
I'm so glad you asked, Arya. I've learned nothing.
The 0.3 RPM for the rotation rate of the Citadel is actually totally fine. We know from various studies that humans don't really like to rotate very much more than 3 to 10 RPM because you can notice the Coriolis effect and your head will feel different than your feet and you're going to get sick and then you're going to spew everywhere, and you do not want that on a space station. So really it's the radius of the wards that has to change. We can use the same equation that we did last time, except this time we're going to set A to what we want in terms of acceleration or g's, and we're going to solve for r. If we solve for r by plugging and chugging, we get a radius, therefore a diameter, of 22.25 kilometers, which is a lot bigger than the stated 12-kilometer diameter, but I guess that's where all that fudge comes in. So there you have it, a single number in a video game that I like a lot explained in not one, but two ways. It wasn't actually all that hard, it did take some digging, but I think we can all say that we learned a valuable lesson. Now, back to the much more important things at hand.
No, bad Kyle.
Okay, fine, jeez. I'm not made out of stone, are you?
Now exiting the facility.
Thank you so much for watching. Thanks to ADEF for his research segment, and thanks especially to all of my very nerdy staff here at the facility for their direct and substantial contribution to this here episode. If you want to join the facility, if you want to get videos early, get private live streams with me, join our private Discord where there's only smart people and no weirdos, go to Patreon. There's some weirdos. Go to patreon.com/Kyle Hill and join the facility today. And hey, if you support us just enough, you get your name on Aria and in every single video. And as you can see, there's so many. So how am I gonna pass this kind of fudging is excusable. I like to say that when you're making sci-fi, you can bend but not break the universe because it ruins immersion. You can find this sort of fudging in Batman. How Batman glides with such small of a cape. You can find this fudging in X-Men, healing factor, Spice, that allows the Mentats in Dune to do all those calculations in their head. Hey, that's probably why they named them Mentats in Fallout. The Fallout protection and radiation protection in Fallout has some fudging. Star Wars has hyperspace. Star Trek has inertial dampers to make stopping not turn you into salsa. There's creature size and ability to fly in Godzilla. There's everything in Doctor Who. There's the growth rate in Alien. There's